It's 10 o'clock, so let's get started. Last week I talked about value, what it is, types of value, and why you would want to put a value on things in the first place. Today and next week we're actually going to do it. We're going to split it in two. We're going to split the methods into two broad groups. And today I'm going to talk about revealed preference methods, starting with the principles, then defensive expenditure, travel cost, and hedonic pricing. It's lecture 5. We're in the middle of the series on valuation methods, and this is of course important for your essay. So most of the stuff for the essay will be done today and a little bit next week, depending on the option you pick. So let's start with the principles of revealed preference methods. Essentially what you do is, well, you want to infer not so much the value but the preference for environmental goods and services, and you do that by analyzing behavior, the actual behavior of people in real markets. But obviously there is no market for oxygen, the stuff that you breathe. There is no market for natural beauty, but there are so-called surrogate markets. And those surrogate markets come in three types. The first, the market, the stuff that you can observe people buying, is a substitute for environmental quality. And we talked about water last week, so let's continue that example. You can drink water from the tap. You used to be able to drink water from the stream. Now you have an alternative option that is buy bottled water, which definitely is cleaner and contains less contaminants than the stuff you drink from the tap. And if you're very concerned about the contaminants that may be in the drinking water that I think Southeast serves up here, then you can always buy Perrier, right? So that is the first kind of substitute market, and the methods that we'll be looking at in a moment are under the heading of either avertive behavior or defensive expenditure. And that would be a measure of the value you attach, in this case, to clean drinking water. An alternative, a second group of surrogate markets has that the stuff that you buy on the market is a complement to the environment. And if you, well, actually a bad example, this is the South Downs. If you want to go visit the South Downs, you can just walk out here and it's 1 minute up the road, right? But suppose that you live further away, say in London, and you would want to visit the South Downs, then you would need to spend money on buying petrol to drive there, right? And the group of methods that rely on the complementary nature of stuff we buy in the market, and in this case natural beauty, is known as the travel cost method, which comes in two flavors. I'll talk about both, the zonal one and the random utility one. The third group of surrogate markets have that the environment comes in a bundle with stuff that you buy on the market. And the example given here is that you can't buy a house that does not have a location. And that implies that you also buy in this case, the wheat fields that are near the house. And if you're Theresa May, you would like to run through the wheat, right? And the crucial thing here is that all houses, all jobs have locations with their environmental characteristics, and you buy the two as a bundle. And the methods used that take advantage of this particular aspect are known as hedonic pricing or hedonic wage studies. So that's essentially what we do. I'm going to get back to all three methods in a little while. The main advantage of revealed preference methods, as opposed to the stated preference methods that I'll be talking about next week, is that we are observing behavior. Real people, real markets, real money. Next week I'll be talking about hypothetical markets, and essentially it relies on surveying people and asking them questions, and then you just have to hope that the questions that they give bear some relation to the actual world out there and with their actual preferences, because there's no reason for people to either know what they're doing, or if they do know what they're doing, to actually tell you the truth, right? So that is the main advantage of revealed preference methods. Another advantage is that it's actually relatively cheap to do this. Cheap in the sense that a decent PhD student can do this in a year, and the cost would be around the 50 to 100,000 pounds per study. And the reason for that is that, going back to the last example that I gave you, if you look at the housing market, you don't need to collect data on this, because real estate agents have collected this data already. You just need to convince a real estate agent to share the data with you. If you use a travel cost study, then oftentimes the parks that you may be interested collect this data already, and you just need to convince them to give you the data. Or if you need to do a survey, you actually ask much simpler questions to people, like, how did you get here, which is something that people tend to know. So it is simply simpler to do this and therefore cheaper. The big disadvantage of revealed preference methods is that if you think back of last week and the characterization or the typology underlying total economic value, you can only assess use values. You cannot look into option values, non-use values, bequest values, those sort of things, because that is not why people travel to the South Downs. They travel to the South Downs to enjoy themselves. They don't travel to the South Downs because they want to bequeath this to their children. That is not a reason to travel, right? So that is the main disadvantage. You can use it only for a small group of values that we may have for the environment. You're looking at the market and you're inferring things from behavior in the market about people's preferences, and that means that you need to make assumptions about how the market is structured, and typically people assume perfect information, perfect markets, perfect rationality, but if those assumptions do not hold, you're in trouble. And of course, when we're looking at the markets, we're essentially looking at things at the margin, which makes it problematic to look at larger changes in the environment. So there's all sorts of issues here, but I hope to convince you that it's nonetheless a useful exercise. So let's look at the methods themselves. And why did this thing turn off? Let's look at some examples. I'm going to start with the defensive expenditure, and here you see an example. This guy obviously does not trust the quality of the air, which is fair. If there's a lot of cars on the road, then they spew all sorts of stuff that you do not want to breathe, and therefore he wears an air filter. He does not wear an air filter because it's comfortable or a nice thing to do. It's because he does not trust the quality of the air. And obviously these things cost money, and this is a defensive expenditure. Defensive expenditures come in a number of flavors. People look at such things as replacement costs or avoided costs. What you're looking at here is the coast of New York and New Jersey. So this is Long Island, right? This is not what the coast looks like. This is an artist rendering of barrier islands in front of the coast. Now, the good thing about barrier islands is that they absorb a lot of energy from the winds, but particularly from the waves. And that means that if you have a big storm coming, if there's a barrier island in front of your coast, it does far less damage. So this is a proposed solution to issues of climate change and sea level rise on this particular coast. And this obviously costs money. If you go further down, further south to the Carolinas, there are actually barrier islands in place. And then the question becomes, what is the value? What would be the value of such barrier islands? Well, if they would not be there, you have three options. Either you can build them at cost, or you could build coastal defenses, stronger coastal defenses, seawalls, groins, those sort of things on the actual coast, or you could accept higher damages, right? So one way to value a barrier island is to look at what would be the cost of replacing the barrier island should it disappear, say because of overgrazing, taking away the vegetation and then the wind blowing away all the sand. You could look at the value of the avoided costs, be it either the seawalls and groins that you would have to build or the flood damage that you would accept, right? And then the minimum cost of these three options would be a way to value a barrier island, right? Now this is an artist mock-up. The reason that I put up this one because it's a nice picture. They're actually building barrier islands in front of the Norfolk coast at the moment, but nobody has taken a nice picture, and that's why we're looking at the United States. So that is essentially the thought behind defensive expenditures. I'm insulting somebody. Or maybe just in the wrong place. Sorry?
Wrong lesson.
Okay. It happens, right? And there are other ways of looking at defensive expenditure as well as avertive behavior, right? So I talked about bottled water as a substitute for tap water. Double glazing as a way to keep out the noise from the road would be defensive expenditure, and it tells you something about how much you dislike the noise that comes from the street. Or helmets that we talked about yesterday. So this is all defensive expenditure. There's also avertive behavior. So going back to our cyclist, he doesn't like the air pollution on the road. He could also have cycled at a time when the road is less busy, right? So his preference may be to go out cycling at 8 in the morning when there's a lot of traffic on the road because that fits his schedule, but he could also have cycled at 6 in the morning, right? Which obviously comes at a cost because most people like to be in bed at 6 in the morning, but that would be avertive behavior. So instead of wearing a mouth filter, he could have cycled at a different time, obviously at a cost to his schedule for the day, right? So all that tells you something about how much people value these things. So let's look at an example. The example is about water quality. It's a bit old. It's in Milesburg in Pennsylvania. This is in 1989, a long time ago. And this was studied by Laughlin, I think her name is, in 1993. And the issue was about giardia. Giardia is a nasty biological contamination. It's the reason why you should never drink out of a stream. It makes you very, very ill. Unless, of course, you have been accustomed to this from a very young age on. I don't think anybody in the room has been, but some people may have. I don't know where you guys are all from. It causes bad diarrhea. Now, what happened in Milesburg was that this crept into the drinking water supply. And then the question is, what did people do? And what is the value of this? And this tells you something about how much do people value clean drinking water. Now, what did they do? Some people boiled their water. Some people filtered their water. Other people purchased bottled water, and you see an example there. This is an example of boiling water. And some people just accepted the risk, right? A bit stupid if you ask me. And then the paper was about, so what did this cost? And if you're boiling water, rather than just drink it straight from the tap, the cost is a bit of time and a bit of energy, right? If you are like this guy and you drive to the next town and get lots of bottled water, you're spending time, you're spending fuel, and obviously you're spending money because bottled water is more expensive than tap water, right? So you can look at all these things, and one of the main responses is actually that it all takes time. So the final result depended heavily on what you assume the value of time is. And that is shown in this particular table. If we say, well, it's just the cost of the energy and just the cost of the bottled water, then for the 500 or so households that were affected by this, the total cost of this particular incident added up to $8,000 US. If you value people's time at the minimum wage, assuming that there's some sort of labor market response, that the people who go to the next town to fetch water are those who are unemployed or at very low wages anyway, then the cost goes up from 8,000 to 18,000. If you instead assume that the labor market is not as flexible as that, but it's really people spending their time rather than hiring in help, then the costs go up to 45,000. So the clear lesson here is that if you're worried about these particular incidents, actually it is the time that people spend and the value of that time that really drives the particular outcome. And we'll see more examples of that later. There's all sorts of limitations with this method. It's pretty simple, as you may have guessed, right? It's just a matter of totting up the costs and making assumptions about what those costs might be. Mitigation is typically incomplete. So I talked about double glazing as a way to keep out the noise. That's perfectly fine when the windows are closed, but if you open them in summer, it is no use. If you go out into the garden, the noise is back, right? So you can sort of look at the cost of double glazing, but that is not the willingness to pay to avoid noise. It's willingness to pay to avoid part of the noise, right? And then the question is, of course, how much of the noise is avoided. There's always the issue that willingness to pay is defined as the maximum amount you are willing to pay, but if the double glazing comes cheaper than the maximum amount you're willing to pay, you reap some consumer surplus, right? Which immediately implies that you're not measuring the willingness to pay, the full willingness to pay, right? It is sometimes very hard to measure all the things that people are doing. So in the Milesburg example I just gave you, they were looking at boiling water, they were looking at buying filters, they were looking at bottled water, but they did not look at people who switched away from water and started drinking other things. And there's another response, right? That if the water is unsafe, then you may actually respond to this by doing less exercise. That means you sweat less, that means you have to drink less water, right? So you may actually reduce your intake of the water, which of course comes at a cost because you're less fit as a result, and you don't get the high of the endorphins. And that particular cost was not included here, right? So there's all sorts of things that are actually important or may be important but are very hard to get your fingers on. And another complication is that there may be multiple benefits. So I talked about double glazing to keep the noise out, but it also keeps the energy in. It reduces the heating costs of your home, and therefore you're double counting or you're undercounting if you're not careful. Right? So all these things need to be taken into account. This method is actually not used very often. It used to be used way back when, but now people prefer the other two methods that I'm going to talk about. And the first is the travel cost method. And a bit of a handicap here. Because not everybody has done their econometrics, right? And there is empirical stuff here. The travel cost method, as you may have guessed, is particularly useful for studying tourism and recreation, or rather inferring the value of the environment from tourism and recreation. The travel cost method was proposed by Harold Hotelling, who you see here in a letter that is fully reproduced here, a letter from Hotelling to the director of the National Park Service. And he essentially did this in one paragraph, and Hotelling was a brilliant guy. So let's look at that. Let concentric zones be defined around each park. The question was how to put a value on the parks that Drury was managing, so that the cost of travel to the park from all points in one of these zones is approximately constant. The persons entering the park in a year, or a suitably chosen sample of them, are to be listed according to the zone from which they come. The fact that they come means that the service of the park is at least worth the cost, and this cost can probably be estimated with fair accuracy. If we assume that the benefits are the same no matter what the distance we have for those living near the park, a consumer surplus consisting of the difference in transportation costs. Comparison of the cost of coming from a zone with a number of people who do come from it, together with a count of the population of the zone, enables us to plot 1 point for each zone on a demand curve for the service of the park. By a judicious process of fitting, it should be possible to get a good enough approximation to this demand curve to provide, through integration, a measure of the consumer surplus resulting from the availability of the park. It is this consumer surplus, calculated by the above process with deduction for the cost of operating the park, which measures the benefits to the public in that particular year. This of course might be capitalized to give a capital value for the park, or the annual measure of the benefit might be compared directly with the estimated annual benefits on the hypothesis that the park area was used for some alternate purpose. So there you have it. That's the travel cost method, or rather the zonal version of the travel cost method. What would you use this for? Creating a site, creating a park, closing a park, changes in the quality of a particular area, or changes in the cost of access. Say you start charging parking fees. And it started with hoteling, with looking at a single site. And then I'm also going to talk about how would you extend this to multiple sites. First we've got to do a little bit of theory. How does this work in the first place? So let's assume that we have an agent who's maximizing utility U, and there's two attributes to this particular utility. One, there is a composite consumption good, right? All the other stuff that we might care about, and then the thing that is of our particular interest, and that is R, and that is our visits to a particular park. There's two constraints. One is a money constraint, so that is how much you spend on consumption, X, and then how much you spend on recreation, how many trips do you make to the park, and that comes at a cost C. And then the amount of money you have is the amount of time you spend working times your wage. And then there's another constraint, that is the total time in the day, then the time you spend working, and the time you spend enjoying yourself times the number of times you enjoy yourself, right? That is the decision, the maximization that you make, and these are the two constraints that you have. Now, this is not a problem you've encountered in micro, but you can actually rewrite it as a problem you have encountered in micro, as follows. So these are the two budget constraints that we have, right? They are the ones I just put up. This equation here is the total cost of each trip, where C is the entrance fee that you pay, or the money you pay on petrol or for a bus ticket. And this is the time you spend. And then if you assume that you also optimize your behavior at the labor market, this is the opportunity cost of time, because you could have chosen to spend that time working, and then you would have earned more money. So this is the outlay and money, and this is the opportunity cost of your time that you could have used for something else. Now, don't do that. Where was I again? Okay, we can bring WT to the other side of the equation and multiply everything through with R, right? That is what is happening here. And then we have an expression for CR that we can substitute back into the first constraint. We have this thing here, and then we can bring WRT sub R to the other side of the equation, and recall that TW plus TR is T to find this particular joint constraint. So essentially what we have done through three substitutions is combine the two constraints into a single one. And then you can just maximize the utility We have two consumer goods. We have one budget constraint, not two budget constraints. So we have a single single shadow price or Lagrange multiplier here, and then you derive the first order conditions. That is that at the margin, the marginal value of consumption is equal to the marginal value of income, standard constraint, or standard first order condition. And what we have for recreation is that the marginal utility you derive from recreation is equal to the shadow price of income times the actual price of going and enjoying yourself. So if you are willing to make this particular assumption, which essentially says that time is money and there is a fixed trade-off between time and income, then recreation becomes a standard consumer good. And everything you recall or have forgotten from micro just carries over. And that means that you can create a demand function that says that if the price is very high, if you pay, say, £25 for a trip, you would not go, it's just too expensive. And if the price comes down, you go and do more and more and more and more of this particular activity until at one point you are saturated because you can't spend all your time at the beach, right? So if you have a demand curve, then obviously we also have a consumer surplus, which is just the integral under the demand curve. So it all just works. Now, how does this work in practice, and what did Hotelling really propose? So we are interested in the value of a site, and it's a bit of nature, so it is green. So what you do is you draw circles around this. And essentially the idea is that if you live in zone 1, then it is cheap to get there, and wherever you are in zone 1, it's roughly equally cheap to get to the particular park. In zone 2, again, costs are roughly homogeneous, and it is more expensive to get there. Zone 3 is more expensive still, and so on and so forth. So that is the first thing you do. And then you create a table, something like this. This is entirely artificial data. I haven't got a clue what this could possibly be. So, zone 1, 2 million people live there, and around 15,000 of them visit the park. And for them, because there's an entrance fee, pretty close, an entrance fee is of say £5, £5, and travel cost of £5. So we have the number of visitors, we have the number of potential visitors, we have the travel cost for these people, and then in the final column we have the rate, that is the number of visits per population, right? And that is 7.5. Then zone 2, 48,000 visitors. You may think this is much more popular to this, but there's many more people. There's 8 million people in this particular zone, and they have a higher travel cost because they're further away, so that's 15, and the rate at which they visit is 6, and you can read the rest of the table. So this is already beginning to look like a demand curve, right? And yes, you can fit a demand curve to this. In this particular case, the visitor rate is 10.5 if there were no cost, if it was free to enter the park. 10.5 people per 1,000 would visit, right? But as the costs go up for every pound that the travel cost increases, demand falls by 0.3 per 1,000, right? Now this is fitted through a process called ordinary least squares, which Julie will talk about next week for the joints. Ordinary least squares, essentially what you do is you take the observed rates, you subtract from that the predicted rate according to some model with some parameters in, and you take the square of that distance, and then you pick the parameters of your model so that the squared distance is as small as possible, right? That is what least means, right? You minimize the distance between your prediction and your observation, and squares means that you minimize the squared distance. And as you may have guessed, there's also least squares methods that are not ordinary, but let's not go into those. Right, so that is what you do, and from that you find these two particular values, 10.5 and 0.3, minus 0.3 even. And then you can actually say, well, what if we raise the entrance fee by £5? Because you have found this relationship between the cost of visiting and the number of visitors, or rather the rate of visiting, you can say, well, let's apply this model and see what would happen. And if costs go up, visits go down, right? And in this particular case, if this model is true and these data make sense, then the number of visitors would fall from the first zone from 15 to 12,000, in the second zone from 48 to 36,000, and so on and so forth. Whereas from the outer zone, numbers would drop from 34,000 to 0 because it's just not worth it, right? So that is how this method works, right? Fairly straightforward. And then what you can do is you can tot up all these numbers, and you can tot up all these numbers, and then draw a demand curve, right? So for if there's no additional admission fee, the sum of the first column is 153,250. If you then have that 5% £5 fee, then that drops to 78,000. If it goes to 10, it drops to 36,750, and so on and so forth. If it goes up to 25, there is no visitors whatsoever. So you have a demand curve, right? And then you can say, well, what is the total value of this park? Well, if the entrance fee goes up to 25, or goes up by 25, then nobody would come, right? And then you have your total consumer surplus of the park, right? That's the difference between the current visitation rate and no visitors whatsoever. So that tells you something about the total consumer value of this particular park. Because if nobody goes, it might as well not be there, right? And in this particular case, the consumer surplus is a little over 1 million. Now, we made all sorts of assumptions here. I assumed a linear relationship between the visitor rate and the cost. You might have assumed a log linear or linear log or a double log. I also used OLS, which is a linear model and therefore potentially predicts negative visits, which is unlikely. That essentially means that people live in the park and sort of like go visit the shopping malls outside. So you should have corrected it for that using a Tobit, but let's not go there. So this is the thing that Hotelling proposed, right? This is the origin of essentially all environmental valuation studies. He proposed it in 1947. It was first done, I believe, in 1953. And this was the first ever attempt to put a value on, a monetary value on nature. The problem with the zonal cost method is that you assume that all these people in these concentric circles are the same. The people within a zone are indistinguishable from each other, and then the only thing that distinguishes people from zone 1 and zone 2 is their travel cost. So you actually know nothing about these people, right? They're just one big blob. But there is actually no reason why you would use zonal data. And the only reason that Hotelling proposed this because he did so in 1947, where it was very difficult to gather data of individuals. Really what you would want to do is give everybody their own zone and just calculate their actual travel costs rather than approximate travel cost of their environment. That is, you ask people where they live or where they particularly came from when they visited, and then use some sort of GIS system or something to calculate how much time it would actually take them to get there. And once you go down that route, you can also ask people about their income and their gender and what have you that might influence their decisions. And that then allows you to take it a step further, because there's problems with these particular studies. And that is that if you sort of use this for a particular site, you completely miss out competition. Because, I mean, the value of a park is not just about that park, it's also, are there good substitute parks nearby, right? That matters greatly, and because you focus on a particular site, you don't know anything what actually drives the value of that park. You just know the total value. You don't know whether it's because they have nice trees or maybe they have lots of junkies in, and that influences the value. But because you get all this in one big bundle, you cannot say what is what, right? So really what you want to do is switch to something called a random utility model, where you actually look at multiple sites and you look at the competition between that. Now, for this you need to use a method that also the single owners haven't done and are not going to do at all. But I can give you the gist of this. So what we observe is a bunch of people, a bunch of individuals. You know them by I, and we see that they visit site G, where G runs from 1 to, for some reason, J. And because we know that some people visited Park A and other people visited Park B, that the fact that they chose this particular venue to enjoy themselves means that they think that this is more enjoyable than the other venue, right? That follows from assuming that people are clever and do what is best for them. So if we know that person I visited site G, that can only mean that she thinks that site G is better in some way, more enjoyable than site J, right? That follows. Now, that's a certain randomness to this. So what we assume is that there's utility derived from this particular visit, comes in a deterministic part and a stochastic part, or a random part, and that is why it's called a random utility model. So So essentially what we say, there are certain structural characteristics of site G, as well as certain characteristics of individual I, that makes this particular site more attractive than the other one. And it's the same condition that I had before, but now we have sort of a structural component denoted by the V and a random component denoted by the epsilon, right? The interesting thing is, of course, what does V look like? And you could make it very simple. You could make this a function of the cost to get there, and that is the C that you have there, and then you should relate this to income as well in some way or another, and here it is simply subtracted. And then you need to have some sort of vector of the characteristics of the site, say the number of ancient trees that you find there, right? So that is the structural part that you impose. Then we have this epsilon, and if you want to make the mathematics simple, well, if you want to make the mathematics tractable, then you need to assume that that follows a Gumbel distribution, and then it all works out, and you can estimate this with a so-called conditional logit model. That's very simple, right? If you do a regression in stata, an ordinary least squares, you give the command regress, or reg if you're lazy. If you want to estimate the conditional logit in stata, you replace regress with clogit, and everything else stays as it was. So it is fairly simple nowadays. Now this model predicts the following. It predicts the choice of going to G, this one particular park, when you could have chosen a whole bunch of other parks, right? So that is what the model predicts, the probability of going there, of choosing G out of all J's. And that probability is defined as the exponent of your structural characteristics divided by the sum of the exponent of all the structural characteristics of all the alternatives that you have, right? So that is why you assume the Gumbel, right? Otherwise this particular trick won't work. And then you have an expression for the likelihood, and you maximize that particular likelihood. And essentially what this does, so with ordinary least squares, what you do is you maximize the square distance between the observation and the prediction. Here, your observation is you went here but not there, right? So you have a series of zeros. I did not go to this particular park, and you have 1, 1. This is the one I chose. But that is not what the model predicts. The model predicts you have a 70% chance of going here, a 25% chance of going there, and a 5% chance of going to the third alternative, right? So that is what the model predicts. And then what you want to do is get your probability as low as possible for the places where you did not go to, and as high as possible for the places where you did go to, right? And then you sum over all those things, and that is what you minimize, because it's again a distance between the one, I did go there, and the probability of going there, 70%. And then there's of course a penalty. I did not go to the second option, so 0 there, but I have a 25% going there, so the penalty there is 0.25, right? So that is what you want to minimize, the difference between the predicted probability and the actual probability, which is always a 0 and a 1, right? A 0 or a 1. So that is what you do with conditional logit. Now you don't have to do that. because there's software to do this for you, right? But that is what the software does. And then you have demand function, and you can look at changes in the quality, you can look at closure of the sites, and so on and so forth. The important thing here to realize is that this predicts where you go, conditional on assuming that you are going somewhere, right? It tells you if you're going to make 10 trips this year, what are the 10 destinations that you're going to choose, but it does not tell you that you're going to make 10 trips this year, right? That is a separate model that you need to make. And if you use conditional logic, you have independence of irrelevant alternatives. That is, assuming that you're into gardens, the relative probability of visiting Wakehurst versus Sheffield Park are independent whether or not Standen is open, or whether you are even aware that there is such a thing as Standen Park, right? So that is an important assumption that you make. So, an example, and then we're going to break. And this is in South Africa, and we're going to revisit the elephants and the lions as well, the big five, right? So, we're in KwaZulu-Natal, South Africa. This is a paper that was published 22 years ago. And we're looking at 4 different parks, and the names are on the next one. The map here is KwaZulu-Natal, which is in South Africa, if you don't know. And we're looking at Italo Park, we're looking at Luluwe Park, we're looking at Umfolozi, and we're looking at Mkunzi Park, all in the northeast of KwaZulu-Natal. Data collection here is relatively easy, because if you want to see wild animals, you need to be there at dusk or at dawn, because at night you can't see them, and at daytime they typically hide from the sun. And these parks are fairly remote from where actually the main population centers are, and therefore the only way to do this is to stay overnight, right? That means you're staying in a hotel. That means that you fill out the registry where you're from, right? Because that is, those are the rules in hotels, right? Questions you can ask is how much welfare is provided, is derived from access to this park, and how would revenues and consumer surplus and so on change in response to changes in pricing. So, 4 parks, I already tried to pronounce them, won't do it again. Parks are different, you can see different animals, they have different, some has a luxury, one is a luxury hotel, the others do not. The sample is restricted to people from KwaZulu-Natal, and there are administrative data, 26,000 bookings, although for the study only 1,000 were used. So you know the address, where people are from, you know with whom they traveled, you know whether they stayed in a tent or in a hotel, you know how long they stayed, and so on and so forth, you know how much they paid. Then you can use the AI systems to actually match them training. You can sort of like see, well, this is how they must have traveled, right? So you can calculate door to gate road distances. You can make assumptions about how much fuel they spent, and you can also make assumptions. Okay, that's what they did. They assumed it because it's South Africa, so you have census data, so you know for each neighborhood the average weights, and that is then assumed that people have the average weights of their neighborhood in which they live, right? And then you can just estimate the conditional logic, as I said, and use it to come up with these particular numbers. So if Itala Park would be closed, that would on average lead to a loss in consumer welfare of 20, this must be US dollars, per trip, right? So it's worth something. Then if you multiply that with the number of trips that are made, you get to a total annual value of this particular park of 195,000. And recall, this is the value to the people of KwaZulu-Natal, right? Because that is, the sample was restricted to people, to locals. So that is how this works, and that is the value to which, or the purpose for this type of exercise. So this is a good time to break. I was wondering how I could be so far in the lecture already, given the amount of time, and the reason is that I skipped this particular slide, which is actually important for understanding the limitations of the travel cost method. So the principle of the travel cost method is very simple. Essentially, you don't pay an entrance fee to get to, say, the beach, but you do pay an implicit entrance fee in the time and money that you spend to get there. So if you look at various beaches, you would see that most of them would only have locals. If I compare, say, the beach in Brighton to the beach in New Haven, assuming that most of you live in Brighton, you would go to Brighton Beach if you would want to. New Haven Beach looks exactly the same, but it is of a bit of a trek to get there, so you don't, right? So that is essentially the whole idea behind the travel cost method, that if it's easy to get to some place, more people would visit, the more expensive it is, the more special the place would need to be. Now, Brighton Beach is special. If you would interview people who are there, you'd see that they're from all over England and from all over Europe. But of course, it's nothing compared to, say, Copacabana Beach or Venice Beach or Bondi Beach, right? And if you would interview people, say, on Bondi Beach, then you would note that there's actually also people from England who have traveled there for that experience. But then you run immediately into a problem, because nobody in their right mind would travel all the way to Sydney just to go to the beach. If you are going there, you might as well see the Opera House as well, and you might as well take a detour to the Great Barrier Reef, right? So then you have the problem that you need to apportion what part of the travel cost and the travel time, 24 hours in a plane, probably £2,000 or so to get to Australia and back. What part of that travel time and travel cost is for visiting Bondi Beach, what is for the Sydney Opera House, what is for Sydney nightlife, what is for visiting your cousin, and so on and so forth, right? And that actually makes it hard. And this is not just true for flying to Australia. Also in your local park, people may be there to enjoy the park, but they may stop on the way back at a shop to pick up some groceries, right? And you need to somehow account for this. An important component here, and that is what I did say, is that you need to put a value on the time that people spend. That is important, but you also need to put somehow account for the quality of the trip. And sometimes the trip is horrendous. If you let's stick with the beach. Sometimes you get to the beach by traveling in a very crowded train on a very hot day, which is not a very nice experience. And sometimes you travel at your leisure in a nice car with a group of friends, right? And then the trip is actually part of the fun rather than a real cost. And somehow you need to take this into account. And all those things, so it's obvious, but at the same time it is actually very hard to put your finger on these things, and you need, if you really want to get it right, you need a lot of very detailed data that you do not necessarily have, right? And the final problem, of course, this is revealed preference. So what we value, if we observe you're going to Brighton Beach, is because you want to be at the beach. Now, it's actually very nice weather out. It's not because of the biodiversity there, or because you want to preserve something for your children, right? No, this is your direct use value. So those are the things I forgot to say. So now I'm back on schedule. So let's look at the final method, and that is the hedonic pricing method. And that is the most examples of hedonic pricing actually have to do with the housing market. And some of you may recognize this house in Dorchester. So if you buy a house, then essentially the price you are prepared to pay for this house is a function of all its characteristics. So the number of bedrooms and bathrooms that are in the house, whether it has original features, and this house definitely does, whether there's good schools nearby, whether there's a park nearby, whether in this case there is water nearby. Don't have to ask that particular question from the real estate agent, and so on and so forth. Whether you can park your car on the premises or on the street, all those things matter to you. And the issue with buying a house is that you buy all these things together. You cannot separate them, and there is not an infinite mix and match of the characteristics of a house. And so you buy them together. So essentially what the hedonic pricing method does is it creates a demand function that has all these attributes that are in there. And then the question is, what part of the price is determined by the upkeep of the house and the quality of the windows and the color of the bathroom, and what part of the price is determined by the characteristics of the neighborhood, being the quality of the school or the number of ethnic minorities that live in the neighborhood, as well as is it near a beach, is it near a park, is it near water. Those are the things that determine the price, and the question is, can you figure those things out? I don't know what happened there. And then once you have estimated that function, you can play around with it and say, well, what if we increase the distance to greenery or decrease the distance to a water body, right? How much would that change the price of this particular asset? And essentially what you would do in hedonic pricing study for the housing market is that you would go to a place such as Rightmove, and I assume you guys are not on the housing market, so this is not something you frequently visit. This is slightly older data, but you would find loads of detailed characteristics there. So obviously the asking price 1.7, 1.8 million, the location, it's somewhere in Hove. It says it has 5 bedrooms and it is detached. But also if you then go into the description, it tells you it is close to a primary school that Ofsted rates as excellent, is the highest category, right? Which is probably true in Hove. And it is near to, the closest shop is 200 meters away or 500 yards or something like that. And then when you probe a little bit deeper, you can sort of go to the ONS and the small area statistics, and you could find out that crime rates are actually very low in Hove, right? and that the average income of your prospective neighbors is actually fairly high, right? You can look up all these things, and I mean, estate agents aren't stupid, right? They put all the attractive features of a particular house in the ad, right? So you can look all those things up, whether it has a garden, what sort of heating is used, often distance to the nearest train station, and everything is in there. And then you can go to the Environment Agency site, and you can look up, is this under a flight path of an airport? The answer is no. What is the air quality? And so on and so forth. What is the quality of the beach nearby? Once you have collected all this data, and here is one example of such data, and I always forget what this is not a painting by Pollock, this is data. So here we have the noise map of London, obviously. This here is the road network, which is related to air quality. So that's where your particulate matter comes into play. That is a map of other noises. This is the map of air traffic noise. This is vaguely shaped like an aeroplane. And this is the type of environment that you're in. So black is completely built up. Blue is water, obviously. Here we see the Thames. Red, I think, are industrial zones, and I think that the gray is agriculture and the green is nature, but that may be the other way around. I always forget this particular classification. So you can look up all these things. You can just, for every location, you can find out road noise versus aircraft noise, and so on and so forth. Once you have that, you can just stick them again in a regression analysis, and you can estimate how the price varies with noise, number of bathrooms, and so on and so forth, right? And then you can manipulate that. And here we see an example. And it doesn't say where this is from. We're in the US somewhere. Okay. Somewhere in the US, and this is not for the sale of a house, but this is for the rental price of a house. That doesn't matter, right? No, it is the sale price. I'm just talking nonsense. So it gives you things that you might expect, right? So older houses sell for lower prices, right? And this estimate means that for every year that a house gets older, the price falls by 0.018. That makes, and it's in thousands of dollars, so the price falls by $18 per year, right? That's not a whole lot. Oh, but it's the log, right? Bigger houses sell for higher prices. Houses with more bathrooms sell for higher prices. Houses that have a pool sell for a higher price. Houses that have more fireplaces sell for higher prices. These are all the things that you would expect, right? These are just nicer houses. If crime rates in the neighborhood go up, then the price of the house falls. If schools are better, then the price goes up. If there's more black people in the neighborhood, then the price goes down. That's not what it says. It says if there's more white people in the neighborhood, then the price goes up, right? We are in the United States. If there's more houses nearby, the price goes down, and so on and so forth. But then it also has, if you're further away from the beach, then the price of the house goes down, right? So there you have an indication of the price of the house. And this is about air quality. If there's the concentration of nitrogen dioxide is higher, this is a sort of contaminant, sort of pollutant that makes you ill, and then the price goes down. If the concentration of total suspended particles, that is just any sort of stuff that floats in the air that makes you ill, then the price of the house goes down, right? So yes, this can be done. This has been done, and here we actually see the same thing. And then you can play around with this and say, well, what if air quality were pristine? How much would house prices appreciate? And that tells you something about how much people dislike air pollution, right? Now, there's all sorts of assumptions that go into this. The key assumption is that the housing market is in equilibrium. Only then can you derive the welfare implications of that, right? That means that people are pretty well informed about all the different opportunities that are on the market. I think this is a decent assumption, right? Because this is sort of like 3 times in a lifetime type of decisions, and people put in a lot of effort into trying to find the right house for them if you're buying, right? It also assumes, and this is a much more dangerous assumption, that there's no transaction costs. That is always an assumption in perfect markets, and transaction costs on the housing market are high because it takes time to find people. You need to hire a real estate agent, or it takes time to find an alternative dwelling. You spend a lot of time searching and informing yourself about the neighborhood you might perhaps move to. You need to hire a real estate agent, and depending on the country, you pay either a little bit of tax on buying a house, or you pay a lot of tax on buying a house. In the US, it's a few percent. In Germany, for instance, the tax you pay on buying a house is 11% of the value of the house. So there are very substantial transaction costs, and that means, of course, that people are reluctant to move, reluctant to buy, and that means that the market isn't as thick as it should be. And also assumes that the housing market fairly quickly finds its new equilibrium. Now, these assumptions explain something that may have struck you as strange. If we look at this list of characteristics, they're all characteristics of the house and its environment. But there are no characteristics of the buyer and no characteristics of the seller. That is as it should be. Or that is as it should be if the market is working well. In the UK, you actually pay a good bit of extra money if you want to buy a house near a good or excellent primary school. And that can be a markup of 10% or 20% even. We are easily talking about £100,000 or so to move from a so-so primary school to a good or an excellent primary school. So that is a very substantial amount of money. And we pay that because when we bought our house, we had children that were about to go to primary school. but the children are now in secondary school, and walking distance to the primary school is irrelevant to us. But that, of course, does not mean that the price of our house has dropped by £100,000. Because the people who potentially would buy this are prepared to pay this sum of money for living near an excellent primary school, right? And even if you want to buy our house, it's actually not on the market, but if you would want to buy the house and you don't have children of primary school age, then you're still competing with other potential buyers that do have such children, and therefore you would still need to pay that premium even if it does not matter to you, right? So because we work in a market, the characteristics of an individual buyer, of an individual seller, is irrelevant, right? What matters is the aggregate of all buyers and sellers, and that includes people who are interested in living near an excellent primary school. Right? So that is an important thing to keep in mind, and something that people sometimes mess up. Other assumptions that you need to make is, of course, the functional form. Is it a linear relationship, log, what have you. Good thing about hedonic pricing is that all the data that you need are essentially there, right? I mean, I put up this picture of Rightmove. They're not particularly keen on sharing data, but they actually don't need to share data. And actually, Rightmove has the wrong data. Rightmove has the asking price, but not the selling price. But actually, if you go to the land registry, you can look up for every house in England and Wales how much people paid for it. Not how much was asked, but how much people actually paid. All that data is in the public domain, and you have the exact address. And then you can use all sorts of other data to figure out neighborhood characteristics. So loads of data available, and people do really care about these things. A recent change in the regulation in England and Wales is that now whenever you're trying to sell your house, you need to disclose whether or not it is at the risk of flooding. And when that was introduced, obviously, people immediately started running hedonic regressions. And yes, if you live in a flood zone, your house is worth less, right? Sort of as soon as that regulation was introduced, as soon as this information became available, the market immediately responded to that. Previously, you had to guess and you had to talk to locals. Has this ever been flooded? And of course, the real estate agent is not necessarily forthcoming with that information, or the guy who's selling it is not necessarily forthcoming with this information. But now that the information is out there in the public domain, it immediately started affecting the housing market, right? So yes, it works. There is a couple of weaknesses there. Some of them are obvious, right? The scope of this is obviously related to things that are immediately around your house. The fact that you can see greenery from your bedroom window is important, not the fact that there is a rainforest somewhere in Brazil. That is irrelevant for the purchase of the house. And of course, as I just indicated, people actually have to be aware of those things, and that has to be information that they can get and interpret. The biggest problem with hedonic house pricing is that it's not just houses that come as a bundle of attributes that you just have to accept. Another important application of hedonic pricing is in the labor market. Now, you may think that is a bit strange. Why would that be? A job is a job. in a year or so you guys are on the labor market. Say you get a job offer in Paris, right? Then your immediate response presumably is yippee, and I can't wait to tell whoever I want to tell these things to that I got this great offer and we're moving to Paris because it's a great city. And in your enthusiasm you forget to ask the salary, right? A bit silly because Paris is pretty expensive. But you can imagine your enthusiasm about spending a couple of years in this wonderful city. And how does that relate to your weights? Well, if somebody were to offer you a very similar job, say in Murmansk, then your immediate response is, how am I going to explain this to my loved one, right? How am I going to convince him or her to move with me to this God-forsaken place in the Arctic Circle in a very repressive country? And if your partner is of the same sex as you, then you probably would not go because you would be beaten up as soon as you step out of the plane, right? And in order to convince you to move to Murmansk, your immediate question is, so how much does this pay? And am I willing to sacrifice 2 years of my life in this city? It better pay so much that when I return I can buy a house, right? Without a mortgage. So it is definitely the negative aspects of an environment that intuitively explain your demand for a higher wage, right? But it's also true that positive aspects of an environment actually means that people are willing to accept lower wages just to live there in that very exciting place. That is true for some people who really want to live in London, right, because of all the exciting things that are going on. It's true for cities like Paris, but it's also true for places like Boulder, right, where essentially you're in the foothills of the Rocky Mountains. People accept pretty low wages compared to their job and their education and so on and so forth, compared to the living cost, to be in that magnificent environment. Now, why do I present this as a problem? You think, well, here we have another market that we can use to study the value of the environment. The problem with this is that the labor market affects the housing market, and the housing market affects the labor market, right? Because house prices are typically a multiple of the average wage, and wages are adjusted for living costs. So what we have here is two simultaneous markets that interact, and both of them are affected by characteristics of the environment. Actually, fortunately for identification purposes, different characteristics of the environment. What matters for your house is the things that you immediately see around, whereas labor is a little bit casts its scope a little bit wider than that. But the housing market affects the labor market affects the housing market, and both are affected by the environment. So then what you need is not just an econometrician who is smart enough to estimate a single equation, but you need an econometrician who is smart enough to estimate a simultaneous set, or a set of simultaneous equations, right? It can be done. It has been done. The big thing that holds people up is not so much the econometrics, but it is rather collecting consistent data on both markets is actually harder to do than you may think, because statistical agencies sort of work in silos. You have your labor market survey, you have your housing survey, and that's done by different parts of this organization, and they interview different people, and you cannot match up the data necessarily in a way that is reasonable or acceptable. So that is one of the main problems with hedonic pricing. That is actually very hard to get it right. And in the essay question that I said, you have data on the housing market, but not on the labor market, because that just doesn't exist in the same format for the same place. And that paper was reasonably published anyway, but it is something to keep in mind. Now, can we apply this? Absolutely. I'm going to look at the amenity value of English nature. And the question here, what is the value of living near a desirable natural area? It was published by Gibbons in 2011. And they looked at all sorts of stuff. Visual amenity, what can you see from your bedroom window? Sports nearby, cultural heritage, cathedrals and stuff. Health facilities, education, and so on and so forth. They looked at 1 million housing transactions. They did not use the land registry, but instead, which has all sales. Instead, they convinced Nationwide, a major mortgage lender, to give them their administrative records. So you know the mortgage, but you also know the price of the house. And obviously, the mortgage lender is particularly interested in knowing the value of the collateral, right? So that data is accurately recorded. And because they want to know the collateral, they also register all the characteristics of the house. And of course, they know exactly where it is, so you can find out the characteristics of the neighborhood. And because you know exactly where it is, you also can figure out what it is close to. So this is the full map that I showed you previously. Previously, I just showed you this particular bit, and I was wondering what is what. But now we actually have the legend with us. So the black bits, as I said, is city. The gray bits, I was wrong. It's actually the suburban parts of London. Then the light green is pasture. Where is the agriculture? Oh, that's all in brown. And on the previous map, there was actually very little brown. So I got informed you. I misinformed you quite a bit. So here you see you see the United Kingdom. There's Northern Ireland as well. So this is where the agriculture is. This is where the cows are and the sheep, right? That is how this map works. And then in red and stuff, you have woodlands. You actually have different types of woodland. The dark green are coniferous. The red are the broadleafs, or the mixed, right? So you have these houses. You have where the nature areas are, so you can calculate the distance to that. Obviously, there's also the national parks. You can find out whether a house is in the national park, right? This is the South Downs National Park, and you're right on the edge of it. Here are the designated green belts, and here are the, if you have good eyes, you have the National Trust sites, which are tiny, and that is why they're hard to see. And then you can run a regression of the house price on distance to all these things. If in a circle around your house, and I don't know how big the circle is, if in the a circle of 1 square kilometer around your house, there is a 1% increase in the amount of fresh water, then your house is worth £768 more. Right? That's how to read this particular thing. Similarly, if you're near a wood, and we like broadleaves more than coniferous. Farmland not so much. We actually really like the neighbors' gardens, right? This is how your house price changes. If you're lucky enough to live in a national park, then the price of your house goes up by 9,000. Greenbelt is also valuable, but less. If you live very close to national trust properties, the value actually goes down. And the reason for that is not so much that national trust is ugly or hateful, but you are sort of have a lot of congestion from the tourists that go there, right? That is the problem with being close to a national trust property. Now, this is the individual characteristics. You can add it all up, and then this particular map results. I don't know where you guys are all from. Green is high. In the very darkest green, the house price is lifted by 35 to 83% above what it otherwise would have been. The dark green is in the far north. For some reason, Scotland has disappeared from this map. It's in Dartmoor and Exmoor, right? Those are the most desirable places to live from an environmental perspective. But our neck of the woods ain't bad either, right? Now, I don't know. That's the Black Country, right? I am not English, so I may be making a fool of myself. But this bit here, really from an environmental perspective, is not where you want to be. Houses can be up to a third depressed in price because of the state of the natural environment in these places. Somewhere near Northampton. Is there anybody from Northampton? Probably doesn't want to admit it. So, very stark differences. And this is one of the biggest expenditures in people's life, right? Buying a house. Very stark differences and very pronounced, spatially differentiated values of the environment. So that is what you would use hedonic pricing for. So to wrap up, we have these three methods: defensive expenditure, travel cost, and hedonic pricing. We look at different types of human behavior, and in all cases this is actual behavior. This is what people have done, real people spending real money, linked to the market in different ways, either as substitutes or as complements, or as Lancastrian goods, as bundles. And we can use it for a range of applications. We can look at health, we can look at the demand for recreation, we can look at the value of environmental amenities and disamenities. The big problem with all these methods is direct use only. So next week we're going to look at stated preferences, where we can also include such elusive things as existence values and option values and what have you. Okay, I hope to see you guys next week.